So usually there are two main axes of rotation when we rotate in the x-axis, when we rotate in y-axis. If it's something else, then by changing the coordinates, by doing shifts and rotations, we should be able to go to x-axis or to y-axis. Anyhow, we have two major possibilities again. So region R is rotated around y-axis, and the region R is rotated around x-axis. And if we do in shells, so if we do slices, it's going to be a different story. Okay. So let's reach these ones, draw a picture. Okay, so we have a region. Okay. And for the first case, axis of rotation here. The second, axis of rotation here. Okay. For the first case, we draw stripe parallel to axis of rotation, and we see our shell. Right? So in this case, R is going to be X, and H is going to be Y top minus Y bottom. So for the first case, when we are rotating around y-axis, integral for volume is going to be integral x equals 2 pi x y top minus y bottom dx. So that's for first one. For the second case, we draw stripe parallel to axis of rotation. You see that's H, that's R. So R equals to Y, H equals to X right minus X left. So we have volume equals Y equals 2 pi Y, X right minus X left, dy. Okay, so two cases, two major cases. So when we're rotating around y-axis, we're going to get dx. When we're rotating around x-axis, we're going to get dy. Let's do one or two quick examples. Region R is bounded by y equals to x squared, x equals to 1, x equals to 2, y equals to 0. It is rotated around y-axis, volume of that solid of rotation. So I'm going to draw a picture per region. Y equals to x squared, x equals to 1, x equals to 2. So that's region R. And we're rotating at around y-axis. So I'm going to give you a minute or two to work on it, because essentially we know what volume is. Volume is integral 2 pi r h dr. R from here to here. Need to figure out what r is, what h is, and what limits of integration. So I'm going to give you a minute or two to work on it. And then I'll try to catch up on you, and we'll see if you agree with my calculations. All right, I'll try to catch up on you. So if I've tried to draw my stripes parallel to axis of rotation, I notice that I will start at x equals to 1 and I'll finish at x equals 2. And if I pay attention to only one stripe, here. Okay. So I notice that that's the radius. So radius is going to be x. Height is going to be, if you like, it's going to be y top minus y bottom. It just in this case, y bottom is going to be 0. Just y top minus 0. Okay. So radius is x. Height is y top, or just y, because we don't have much. And we start making our stripes at x equals to 1 and finish at x equals to 2. So from 1. So we're going to get volume equals integral x equals to 1, x equals to 2 pi x times y top dx. Here, y top comes from parabola y top equals to x squared. So we're going to take it and substitute. So we're going to get integral x equals to 1, x equals to 2 pi x squared dx. So 2 pi is a constant. X squared times x is x cubed from 1 to 2. So we're going to get 2 pi x to the 4 over 4 from 1 to 2. So 2 pi 2 to the 4th over 4 minus y to the 4th over 4. 2 to the 4th is 16. 16 minus 1 is 15. So we're going to get 2 pi 15 over 16. 15